In this video, we're going to be doing the chapter review problems from 618. I'm going to pick some random problems, and I'm going to show you guys how to do them so that you can have some more help for your test tomorrow. Okay, so first, number 30. If you can, don't forget, you need to be able to factor something else out first. So with the 8 and the 4, I noticed that I have a 4 in common with both of those, and with the x squared and the x, there's an x in common. So I can pull out a 4x or factor it out, and I will be left with, should be 2x. 4 times 2 will give us 8. X times x will give us back to x squared. 4 divided by 4 is 1. I want it negative, and it's still equal to 0. Something times something equals 0. So take both of those somethings and set them equal to 0. So in this one, if I divide by 4 on both sides, 4 divided by 4 is 1, 0 divided by 4 is 0, so x equals 0 is one solution. This side add 1 to both sides, left with 2x equals 1, divided by 2, 1, divided by 2, x equals 1/2. So you have 1/2 and you have 0, those are your two solutions for number 30. Number 33, 21h squared equals 7h. We want it to be set to 0 so that we can actually factor something out and then solve both for 0. So if I subtract 7h from both sides, that'll give me 21h squared minus 7h equals 0. With the 21 and the 7, my greatest common factor is 7, h and h. The greatest common factor is h. 7 times 3 will give me 21, and h times h will give me h squared minus 1 equals 0. Something times something equals 0, so take both of them and set them 0. So h will be 0, add 1, 3h equals 1, so h will be 1/3. So you have 0 and you have 1/3. For number 37, the next few that we're going to be doing, whoops, I skipped number 36, so I'll go back and get it. But number 37, it just says factor the trinomial. So all we're going to be doing is factoring. This is going to be our double bubble stuff. So we have a times a will give us a squared. They multiply to be this number. They add to be our positive 5. So if they multiply to be a negative, the only two signs that they can be are plus and minus. The difference has to be 5. So I'm going to have 12 and 7 multiply together to be 84. So if I have plus 12 minus 7, 12 minus 7 will give me 5a as my difference. As promised, I'm going back and doing number 36, still just factoring the trinomial. So we're going to have our double bubble, so there's nothing else to factor out first. There's no greatest common factor between all of these. b and b will give us the b squared. We have a negative, so I want to be a positive and a negative. Because they multiply to be a negative, it cannot be two positives and it cannot be two negatives. Multiply to be 14, difference is 5. So I have positive 2 minus 7. 2 minus 7 is negative 5. 2 times negative 7 is negative 14. 41, still factoring. There are no greatest common factors. We have a 1, we have an 8, and we have 15. 15 does not have a c, so I cannot pull out any c's. So we're going to double bubble. We're just going to straight up factor this guy. I have c and I have c. Multiply to be a positive, so it could be either both positives or both negatives. Add to be a positive, so they both have to be positives. Multiply to be 15, add to be 8, so I'm pretty sure I'm going to have 5 and 3. 5 times 3 is 15, 5 plus 3 is 8. There we go. Still factoring trinomial, no greatest common factors between anything, so I can factor him with my double bubble. Y squared, so they have to be y and y. Positive, so they multiply to be positive, so they can either be both positive or both negative. Add up to be negative, so they have to be both negatives. Multiply to be 21, add to be 10, so 7 and 3. 7 times 3 is 21, negative 7 minus 3 is negative 10. 44, we have 4n squared plus 3 equals 7n. I want this to be equal to 0, so I can actually factor this and solve it out. So I'm going to subtract 7n from both sides. So I have 4n squared minus 7n plus 3 equals 0. Notice I have a number in front of my n squared. So what I can do is take this number, multiply it by my last one, write it off to the side, and circle it. So my new equation that I'm going to factor is going to be n squared minus 7n plus 12 equals 0. No greatest common factors, so I'm going to factor this. I have n and I have n. Multiply to be a positive, so they're both the same sign. They add up to be a negative, so they must both be negative. Multiply to be 12, so I have like 6 and 2, 3 and 4, 3 and 4 out to be 7. So I'm going to use 3 and I'm going to use 4. Still equal to 0. But don't forget about your 4. This is where we have to bring it in. This is our bottoms up. 4 over 4, this will reduce. Reduce as much as you can. 3 over 4 will not. So what we do, here's our bottoms up. We have 4n minus 3 times n minus 1 equals 0. Something times something equals 0. So take both of those somethings and set them equal to 0. So n will be 3 over 4 when you add the 3 and divide by the 4, and n will be 1 when you add the 1. There are both of your solutions. 46, doing the same thing, solving the equation. Notice it is have an equal sign, so we will be solving it. Going to need to equal 0, so I'm going to subtract 5 from both sides. So 6z squared plus 13z minus 5 equals 0. I have a number in front of my z squared. There's nothing that I can take out of my greatest common factor, so this is going to be the bottoms up method again. So I'm going to circle my 6 because I'm multiplying by it, so z squared plus 13z minus 30 equals 0. Factor this, equal to 0. First terms are both z's. I have a minus sign, so I'm going to want a plus and I'm going to want a minus, so their difference will be 13. 15 and 2 add up to be 15 and negative 2 add up to be 13, and they multiply to be 30. I have positive 15 and minus 2, so that will give me a positive 13 as my difference. Don't forget the bottoms up though. So you have to divide by 6 and reduce as much as you can. So we have 1 over 3 in that side. 15 over 6 reduces to 5 over 2. We have a 2 to bottoms up on this one and a 3 on this one. So we'll be given 2z plus 5, really bad at 5s, 3z minus 1 equal to 0. Something times something equals 0, so one or both of them must be 0 in order for this to be true. So 2z plus 5 equals 0, and 3z minus 1 equals 0. Solve for z in both of these. Subtract 5 minus 5, so 2z equals negative 5. Divide by 2, so z equals negative 5 over 2 is your first solution. This one you would add 1, so 3z equals 1, and z equals 1 over 3 is your other solution. So 1 and 2 solutions for this one. 53, this is where they start to get a little bit trickier, so you have to remember your steps. First step, factor out your greatest common factor if you can. We have a 12, 12 will go into 48, so I can factor out a 12. There's no n with the 12, so there's nothing else to factor out from here. So I'll be left with 1 minus 4n squared. Look, 1 is a perfect square. 1 times 1 will give you 1. 4n squared is a perfect square. 2n and 2n. So what this is, since it has a minus sign between them, is our difference of squares. This is our special case. We have a 1, we have a 1, we said 2n and 2n. Difference of squares, so we have different signs. There it is, factored out. This is one of our special cases. If you don't see it right away, that's okay. Is there anything to factor out? No, because we have a 1 with the x squared, 20 with the x, and 100. So there's no greatest common factor with the numbers. The 100 does not have an x, so I cannot factor out any x's. So all this is going to be is just our double bubble. So we have x times x will give us x squared. Multiply to be a positive, and they add to be a positive, so they both must be positive. Multiply to be 100, add up to be 20, so 10 and 10. Look, x plus 10 times x plus 10, they're the same thing. So that's like saying x plus 10 squared. This would be your final answer. This would not have to have the x squared. With 61, this is another one of those cases where you have to factor out everything as much as you possibly can first. We have 5. 5 will go into 125, so we'll have 5 on the outside is our greatest common factor with s to the fourth and s squared. Our greatest common factor is s squared. So I have 5s squared. To get back up to s to the fourth, 5s squared times s squared will give us s to the fourth minus 25. Your first term is a square. Your second term is a square. There's a minus sign in between. So this is our difference of square cases. S times s will give you s squared. 5 and 5 will give you 25. Difference of squares, so one's a plus, one's a minus. There's your solution. 62 is very similar to 61. You need to be able to factor out what you can first. 3 will go into 147. We'll be left with 49 times. So I'm going to factor out 3, n to the fifth and n cubed. Their common terms are n cubed. Make that a 3. So I'll be left with 49 n squared minus 1. 49n squared is a perfect square, s 7n and 7n. 1 is 1 and 1, minus in the middle, so once again it's our difference of square terms. So I'll have 3n cubed on the outside still, 7n, 1, different signs because it's a difference of squares. There's your final answer. Hopefully this has helped. Good luck on your test tomorrow, and enjoy the rest of your night.